Example of slab bridge design. I will design a sample slab bridge for you. A slab bridge is a bridge in which we have slab resting on the abutments and directly taking the loads from the wheel. There are no girders, there are no, what should I say, no diaphragms, there are no transoms, no piers. A slab resting onto abutments. Okay. You have seen this type of bridge maybe in I think in Dammam. Also, if you go to Medina from Bureda to Medina, there are some small U-turns under the road. Have you seen?
Yeah.
So over there, I think they have used these types of slab bridges. If there's a channel, water channel, you can have. I want to show you some pictures of the slab bridge before I start, but unfortunately my computer got hang. And okay, so what we are going to design today, it is let me write the example first. Design a simply spotted. What is the example which I am going to solve today? Design a simply spotted solid slab bridge. Solid slab. Normal reinforced concrete bridge Okay, how much should be the span of the bridge? Tell me, any value?
20 meters.
More than 60.
20 meters is too much.
More than 60.
You want 6 meter, 6.5 meter, 7 meter?
Yeah.
Okay, let's say the span of the bridge is how much?
7.
Bridge span. Bridge span is equal to 7 meter. Or if you want, you can take it 8 meter. So the bridge span, let's suppose it is equal to 8 meter. And what type of loading we will use? We will be using HL93 loading. HL93 loading. And the bridge is how many lanes? 2 lanes, 3 lanes? 3 lane. 3 lane is a bit wider. Slab bridges are mostly for two lane bridges. I think let's suppose we have 2 lanes. 2 lanes of road. Because either we have 2 or we have 4. Do you understand?
Yeah. Well,
2 meter. Either we have 2, we have 4 or 6. 3, maybe at some point you have 3, but most of the time we have either 2 lane road, 4 lane or 6 lane. If it is a one way, like we can consider it as a 2-way. We have some shoulders on the left and right. This is shoulders, you know, shoulders on the left and right. But Mostly we have 2, 4 and 6 slab bridge. Let me show you slab bridge so that you understand what exactly I'm talking about. Something like this. Can you understand this one, this slab bridge? Okay. Also, maybe like this. This is, you are looking in the longitudinal direction. Let me open in a big view. Open new window.
Where is it? Then on your way.
There are many, I know, but just to explain you these bridges, I'm just showing you the picture that what exactly we are going to do in this class, so that there should be no questions. Sometimes, even for a long span, we can use it. Like for example, like after every 7 meter, we provide one pier and we rest one slab, another slab, third slab. Okay. Like many span, but we have to design just the one span. For example, if there are 3 span, 7 meter, 7 meter, 7 meter, or 8 meter, 8 meter, 8 meter. So what you do, if your spans are simply supported, just put 3 slab bridges, and you have to design just one slab bridge. This is a case where it is just a single span. Okay. This one is abutment, this one is also an abutment, and this one is a slab bridge. No girder at all. Okay? You can see there are no girders in this bridge. And if we have continuous slab bridge, my computer has grown old and now hopefully I will buy a new one. For example, is it a slab bridge? It's a continuous, or I'm not sure whether there is a spacing here. If they cut it if they cut at this point, it is a slab bridge. But if it is going straight, then it is a continuous slab bridge.
There is a line, look at.
Yes, there is a line, I think. So it is a open. Yes, I think it is simply supported. I can see a line here, a cut. So if there's a cut, it means this part is simply supported, one panel, another panel, and third panel, like this. So it is also a type of slab bridge. But you have to design just one span. You have to design just one span and then put it on, like it could be like 3, 4, 5, whatever you want. It could be a long bridge. But you have to design just one span. So this is, you can see it is not a highway, it is a small, maybe 2-lane road. But for the highways, we have bigger or wider bridges. So this is the bridge which we are going to design today. Slab bridge. Okay. 2 lanes of road. So there are 2 lanes, and the surface, the bituminous surface, the thickness of bitumen is 75 mm, asphalt thickness. FC prime, you can take how much FC prime you want? 20, 25, like what? How much FC prime do you want? Concrete strength. 20? 25. Do you have calculators today? Just one guy. Okay, so concrete strength how much? FC prime? How much you want? 20, 28, 25?
28.
And steel strength FI? 300, 420, 520?
420.
Okay. And you want barrier? Footpath and barrier?
Yeah.
Okay. So let's suppose you want 1.2 meter wide footpath on each side. You want barrier 380 mm wide barrier at each edge. Okay. So the lane width, I give you the lane width. The standard lane width could be from 3.6 to 4 meter. Let's suppose the lane width is 3.8 meter. The lane width is equal to standard barriers are already present in ASTRO. So the size of a standard barrier is given in ASTRO, so you know how much is the size. And if you know the cross section, you can calculate the load per unit area or per unit length.
So, how much the weight? 1.2 or
1.2 meter. For example, standard, let me type here, standard ASTRO barrier. Like this. You have standard barriers. Each dimension and everything is there. So if you see this barrier, the dimensions are known, everything is known. So what you need, you just need, it is 16 inch, for example. How much in millimeters? 16 inch, how many millimeters? 16 multiplied by 25.4.
400, I think.
25.4.
400.
406.
So around 380.
No, around 400.
Around 400. So this is what we have. Okay. So this is a standard barrier. For example, there is no need to design this barrier. So we have it. So I will provide the same, and I will give you the load of the standard barrier. The standard barrier load is somewhere. The self weight of the barrier is 4.68. Loading I have mentioned, it is HL93. So when I say HL93, how many loads are there in HL93? Three. Which loads? And there are 3 loads in HL93, okay? So any information which is left till now? This span, you want clear or you want center to center? Clear span is from the edge of support, for example from here, from the edge of support. And center to center span or effective span is from the center of the support. So this span is clear or center to center? Tell me. Okay, we need center to center for the moments and shear force calculations. But if we have the clear span, we can add the size of the half of the width of the column or support to get the effective span. Okay, so this is the data which we have, and I hope we did not miss anything, but if we missed anything, we will discuss during the example. So what would be the first step? The first step is to draw the cross section and the longitudinal section to idealize your bridge. Do you understand? That is the first step. This is the data. So the first step, we have to draw the cross section and the longitudinal section of the bridge. Okay. So first, let's draw the which one? Cross section or the longitudinal? First. Cross section. Okay. So let me draw the cross section of your bridge, and please tell me if I do any mistake. There are three things. One is the plan view of your bridge, plan view of the bridge. Number two, cross section, and number three, longitudinal sections. But most of the time, longitudinal section and cross section are enough. But if someone asks you, please show the plan view, you can also draw the plan view. Okay? For your convenience, would you like me to draw the plan view? You want to see the plan view?
Yeah.
Okay. Okay. So first, let's draw the plan view. Plan view, for example, you want to take the traffic this way or this way? Because it will change. I mean, you want north, south is your traffic or east, west is your traffic?
East, west.
East, west. So it means your road is like this. Am I right? And you want this bridge to be single span or multi span? I mean, like 3 span, 4 span? Like, for the time being, let's talk, it's 1 span, okay? Because otherwise I have to show a long cross section. Here is your abutment. How you can show your abutments? You can show the abutments like this. By 2. Okay. On that side you can have approach slab or the road, and from here your bridge is starting. And then on this side it is how much? 8 meter? 8. Okay. So the other apartment will be somewhere here. So on this side you have road. On this side you have road. The barrier is here. It is very important. This is one of the very important information about the layout of your bridge. The barrier is here. This is your barrier. This is the barrier, and then this one is the footpath. Okay, and this is the center line of the road, and this could be the shoulder line. So what is this? This is footpath. What is this? It is barrier, and these are the 2 lanes. So now let me show you the dimensions. For example, from this center to this center it is 8 meter, because we considered it center to center. And now let's talk about the dimensions on this side. How much is this total dimension?
2 meters.
1.2 plus 0.38, 1.58. So it is 1.1580. Let's show all the dimensions in millimeter. And how much is this?
This one is
How much is this?
300. 380.
Every dimension is in millimeters. So, did you understand the plan view of your bridge? This is the plan view. Now, let's talk about the longitudinal view. How it will look in the longitudinal direction. This is the first abutment. And here you have second abutment. Okay. And then, for example, if it is your, this is your slab. This is a slab bridge, and this one is the barrier, and then you have approach slab on both sides. So this is, you can say this is a barrier. So this is the longitudinal section of your bridge. The slab span is from center to center is 3.8 thousand millimeters. It is all concrete. This is all concrete. And on this side you have soil and soil. This is open. So this view is the longitudinal view of your bridge. Okay. If how much should be the size of this column? Just you can tell me any idea, because I want to calculate the clear span.
Rectangular or
Anything. For example, if it is rectangular wall, if it is a wall, so it will be something. It will not be more than 400 mm, or not be more than 500 mm. 500, two things. So let's take it how much? 400 mm. So if it is 400 mm, how much will be the clear span?
Minus
7,600 millimeters. So this figure shows the elevation of your bridge. Elevation of the longitudinal section. And now the cross section. The cross section actually I should draw this way. You understand? The cross section I should draw this way. But I just rotate it, and for convenience I show like this. Okay? How would be the cross section of this bridge? This one is the barrier, and then footpath, and then the bridge, again footpath, and barrier. Okay, so this slab bridge will look something like this. All is concrete. I shown the barrier as a part of the bridge. If you can consider it, or if you want to isolate it, you can isolate it. This is a barrier, footpath, barrier, footpath. How much is this?
158.
This is 380.
Yes.
80. And how much is this?
1,200.
1,200, 1,200. And then 380. And what about this? For example, if it is a 2-lane road, so how much will be this? 3,800? 3,800. And how much is the total width of the bridge? How much is the total width of your bridge? No. 8.76. $10,760 millimeters. Okay, so this is how this bridge will look like. If it is a reinforced concrete, just put the girders below it. It will become reinforced concrete girder bridge. If you put the girder below this, whenever we design a bridge, it remains like it. For example, this portion is known as deck. All this is known as deck. Okay. Did you understand everything till now? Or you have any question? Have you understand how I have plotted all these drawings? Any question? Because in your exam, I can give you the data and I may ask you to draw something, maybe cross section, elevation, or plan. You have to carefully read the exam, that what exactly I want to know, or what exactly I need from you. Okay. Next. So next is the first step. We should calculate the thickness of the slab. What would be the next step? Thickness of slab. It is cross section. So how we can calculate the thickness of slab? For example, H minimum. Let's see how much is the H minimum recommended by the ASTRO. We have table for H minimum. And this table, I think I have shown you from ASTRO. This is the strength limit stage. But I have the snapshot of the ASTRO here. It was in my previous lecture. Okay, let's seek help from ASTRO. I cannot see anything here. Okay, just a minute. There was a table